You may have heard that physicists are spending an awful lot of time and energy looking for something very arcane, a particle called the Higgs boson. What I'm going to try and do with the full power of Guardian resources behind me is explain to you what a Higgs boson is, how do you look for it, and why does it matter if you find it anyway? The tools I have to explain this to you are lavish as the Guardian can afford. They are a tray from our canteen. I have a bag of sugar and some different coloured ping pong balls. This tray is the early universe. Let's fill it with particles. So in the early universe, all of these particles weighed absolutely nothing. They had zero mass, and they all move around at the speed of light. They all behave like the photon. About a trillionth of a second after the Big Bang, something called the Higgs field switched on, and it grew as the universe grew. Now let's take another empty universe and fill it with our Higgs field. Here is our Higgs field. This is our early universe with the Higgs field switched on. Stay with me. Let's grab some quarks and electrons. Heavy particles like top quarks get very bogged down in this field. And the more bogged down a particle gets, the heavier it is. The field essentially interacts with different particles to different extents. Some particles, like the electron, are really light. When the Higgs field switches on, the effect it has is to introduce a drag on particles that are going around in the universe. They're no longer all zipping around at the speed of light. Now, there's an exception, although not a unique exception, is the photon. The photon remains massless even after the Higgs field is switched on. So even though the Higgs field is there, the photon moves through it as if it's not there. So it doesn't get any drag, it doesn't feel any resistance. It continues to zip around at the speed of light, and so do other particles that are massless in the universe. All the other ones get a weight from doing this. Now, what is the Higgs boson? The Higgs boson is represented by these tiny grains of sugar. What scientists are looking for at the Large Hadron Collider is a grain of sugar, in this analogy, which is a particle of the Higgs field. The particles of the Higgs field, the Higgs bosons, make up that Higgs field. Now, how do you look for one of these at the Large Hadron Collider? That's what I'm going to show you on the board now. At the Large Hadron Collider, which is the largest and most powerful particle collider in the world, it's 27 kilometers in circumference, and it's 100 meters under the countryside between France and Switzerland. What you have is an enormous pipe which fires protons at each other at pretty close to the speed of light. These are the protons, and they whiz around this huge underground tunnel, the speed of light, and they crash together inside big detectors. These things are vast. They're about 3 stories high. They crash together inside these detectors, and that is where you look to see if Higgs bosons are discovered. So what happens? Well, when these two particles collide, and it's actually the constituents of the protons that collide, you get a very tiny but very energetic flash of energy. You will get electrons coming out, you will get quarks coming out, you will get light coming out. Occasionally, you'll get a Higgs boson produced. Now, one of the problems is that the Higgs particle doesn't hang around waiting to be measured. As soon as it's created, it decays into other particles itself. And these can often decay into their own particles, which makes looking for it very, very difficult and time-consuming. The thing about finding a single, simplest form of Higgs boson is that it rounds off your theories. It gives you a really nice package of understanding for certain laws of nature. Finding something more complex is better because it gives you a road into a new area, a new realm of physics. And that's really what scientists have their fingers crossed for, is that when they really look at what this particle is about, they find something in there which opens up this new door to understanding which they don't have at the moment.